All right, we are covering 5-7, which is solving quadratic inequalities. We're going to solve them both by graphs and by using algebra. So quadratic inequalities look just like linear inequalities, except of course quadratic equations are used instead of linear equations. So they have one of our inequality symbols, less than, or equal, greater than, or equal. And essentially when you graph it, you're going to solve it the same way or very similarly to graphing linear. You're going to graph the function and then shade above or below it. So to graph an inequality, you want to graph the parabola that defines the boundary. So that's this piece, the actual quadratic parabola shape. And just like linear inequalities, if you have an equal sign, the boundary line is going to be solid. If you do not, you're going to use a dashed line for the boundary. And then we shade above the parabola if we have y is greater than or equal, and below the parabola if y is less than or equal. So it's the same concept as linear, it's just the shape of the graph is different. All right, graph y is greater than or equal to x squared minus 7x plus 10. So we're going to use our process that we know for graphing. We know the y-intercept is 10. We can find the vertex. So remember, the x-coordinate of the vertex, negative b over 2a. And then we plug that value into this equation to find our y-coordinate of our vertex. So they've done it for us, and it's 3.5, negative 2.25. So we graph our vertex, we have our y-intercept, and this is going to be 3.5 units to the left of the vertex, so we're going to go 3.5 units to the right and get our symmetric point. And now we have our graph. Notice this isn't greater than or equal, so this is going to be a solid line right here. And now all we have to do is shade. So it says y is greater than that equation or that quadratic function. So we want to go above the graph. So above the graph is going to be here. And if you notice, if you looked at y, you can see this is where y is going to be bigger and bigger. So since y is greater than this, we want this part of the graph to be shaded. And as I've shown you, if it were y were less than, we would shade underneath here. So inside of the graph, if it's an upward looking graph, inside is going to be greater than, outside is less than. If it's a downward, greater than or equal is going to be here, and less than or equal is going to be outside or inside, sorry. So you have to look at whether it's opening up or down to determine where the greater than or less than are. All right, one for you to do. So that's graphing. We can also solve quadratic inequalities in one variable. So in this case, x is our only variable with a number line. So for AND statements, both of the conditions must be true. For OR statements, at least one of the conditions must be true. So we're going to look at our conjunction and disjunctions again when we solve this. All right, so let's look at an example. Solve the inequality x squared minus 10x plus 18 is less than or equal to 3 by using algebra. So we're going to turn it into an inequality first, and we're going to put it in standard form by adding 3. And then we're going to solve this quadratic equation using one of the methods that we know how to. This turns out it's a factorable one, and I think pretty much all your problems are going to that you solve by algebra are going to be factorable. So this factors into x minus 3 x minus 7. So the solutions then are going to be x equals 3 or 7. So we're going to put them on a number line, mark those 2 points. So here's our critical values, and these actually are going to be solid eventually because we have an equal sign. But we need to figure out whether we want to shade here or here. So how do we do it? We're just going to test some points. So I would choose the one in the middle, because pretty much if the one in the middle doesn't work, then you're going to be shading outside. So they're testing 3 points just to cover all their bases. So x equal 2 is one of their test points. They plug x equal 2 into our original equation. And what do they get? They get 4 minus 20 plus 18 is less than or equal to negative 3. This is going to end up being 22 minus 22 less than or equal to negative 3. That's not true, so this is not part of our solution. Then they're going to check x equal 4, which is this point. Plug it in, they get 16 minus 40 plus 18 less than or equal to 3. This is going to be 24 minus 40, which is negative 16 less than or equal to 3. This is true, so we know that 3 is in our solution. 4 is in our solution region. And then just to be sure, they'll check 8. If they plug 8 in, you're going to get 64 minus 80 plus 18 less than or equal to negative 3. And this becomes 82. So this again becomes 2 less than or equal to negative 3, which is not true. So we know that our solution is in between. And that means this is algebraically what our solution is. This is the number line, and this is how you should write out your solution numerically. X is between less than or equal to 3, greater than or equal to 3 and less than or equal to 7, or interval notation between 3 and 7. All right, so those are the 2 examples. This is one for you to try algebraically. Bring your questions to class, and this is your homework.